Good morning. Good morning, everybody. This is Engineer Suraj Singh speaking from Bharat, India. On this day, April 30th, 2021, Friday, and this is last day of April 2021. Tomorrow, May 1st to the start, 21 plus 5, 26 number of month to the start. Today is last day of month 25 because 21 plus 4, 25. 25 shall turn to 26, 6 will bring tension, of course, romance as well happiness. Title of this talk being Civil Field Engineering, Designs, Construction, Methods, Contracts, EPC, AnnexSL, Organizations, Communications, Coordinations, Quantity, Quality, why be behind quality of concrete, standard material. And on top of this, I like to commence with a small brief discussion on COVID-19. COVID-19 state as it was yesterday on 29th April. Reported cases in India, Bharat, 3.79 lakhs infections and more than 3,000, more than 3,000 lost cases. Governments at center in this country claim a lot. They claim a lot, but these claims are not logistically based. These claims are not reasonable. What is being seen or witnessed on ground reality is far higher than what is being registered. It's unfortunate that data are not well reliable. Every day I go through publication by ministry and record on my sheet and then publish after my comments are finalized. I publish this on script.com for your assistance because analysis of every action is very important. Government of India reports data based on data, but it never ever equips people about what does it mean when we get some data. It is duty of that data provider to provide some expertise based comments on that. What does it mean? Just giving data got no meaning at all that I understand. Only data giving has no meaning. It's really unpleasant if you just give data to people and let them understand themselves. 98% people do not understand what is analysis, and if they are not given any feedback, they just act as okay, just like a news. We get news item, okay fine, this is news, broadcast, and that's fine. COVID today in our India, Bharat, has spread intensively in all parts of this country. Kerala, Karnataka, which were till now not touched by this very intensively, where the full coverage are also touched. Delhi was touched before and many other states have been touched, but now it is spreading rapidly and beyond imagination. Whatever is reported, I think it's only very small fraction of what is factual. I'm not blaming someone. I know no government wants to give correct data, true data. They want to hide, and this is character of every government, to hide something so that its credibility goes on in continuation of positive acceptance. But facts cannot be hidden for long, and particularly when it's question of life and death. I've seen many videos of facts which actually you can say that this COVID-19 currently ongoing in our country is like a pralay. Pralay means destruction. This is not pralay of earth, this is pralay of humanity. If every day thousands of people die, 3,000, 4,000, I think it's not less than 10,000 to be very frank. If you just multiply by 3,000 something, you get around 10,000. Let us assume 10,000 people die a day, and let us assume in place of what government says 3.79 or 3.5 lakhs people impacted upon every day or contract COVID, I say also multiply by 3. So you will get that 1 million people are impacted or contracting every day COVID-19 and 10,000 people losing their lives. That is real situation? I think so, maybe more. And if that is situation, you can say, they themselves say, government report, that 20%, 21%, 22% people who have been tested are exposed, are detected COVID positive. Okay, I say, okay, let us say 20%. This means 26, 27, 28 crores people must have contracted, if you just take based on this pro rata. And if that's the case, then it's a big issue. If you have 25 to 30 crore people contracting COVID currently, who shall handle this? Point is that whatever infrastructure medical we have in our country is not efficient, cannot be efficient to handle people like this. Let us say period of 6 months, and this 25 crore is spread for treatment of assistance. This means 4 or 5 crores monthly. 4 or 5 crores monthly, if you take into consideration, you have to treat 5 crore people monthly or 6 crore people monthly. What does it mean? 20 lakhs people a day. I say 6 crores, 600 lakhs, 600 divided by 30 means 20 lakhs people, 2 million people a day you have to treat, you have to help, you have to assist them. Right? 20 lakhs people a day. Do you have so many beds? Do you have 20 lakh beds all over country? Do you have so many doctors? Do you have so many, infrastructural transportation? I saw one video, we would watch the video of Prayagraj or Allahabad, cremation ground, open cremation ground. Ambulance after ambulance after ambulance arrived there. And there were a lot of complaints, many complaints from people of that area. Charges were too high, ambulance charges, cremation charges, wood charges were so high. Oxygen was not available. Patients were not admitted. And I also saw one video of that hospital, biggest hospital in that area. Line in one bed, 2 or 3, and there were no facility that should be given to every patient. This is super critical situation where people have been left to their own mercy, and they have been left as if they are vegetables, as if they are some commodity. Government tries to state, government claims there is no problem. I'm not talking alone for UP, I'm talking for whole nation. Same thing in Delhi. All over, I've not gone through, but sense tells you, reports tells you. All reports would tell you it could happen like this, it could happen like that. And if that is state of this COVID-19, what to say? I'm not blaming government, I'm not blaming people. I am blaming nation. Government's responsibility is to impart health to everybody. Government has ignored this problem. Government thought before that they have got victory over COVID-19. I don't know on what basis, what was logic behind that. If you declare something, it should be logically based, it should be scientifically based. You cannot simply imagine and say there is nothing now, no problem now, everything is normal, as generally government ministers claim. Everything is normal. There is no problem in oxygen, there is no problem in beds, there is no problem about anything. They say that. But that is far from reality. Fact is, how long can you avoid? That point is more important. Rather than thinking that everything is okay, not okay, you cannot simply imagine. This is not mathematics, let us assume this. This is not some equation, let us assume this and prove it. No, this is not science, this is not engineering. This is life of people. This is people who have been suffering. This is people, this is a nation that has been suffering. There should be quality control everywhere. There should be quality criteria everywhere. But where is quality of announcement? Can you announce whatever you want to announce? Point is that, should we accept everything government says when ground is speaking something else? You know all. I'm not reliable onto television news nowadays, because television news are 80% fake. More than news, they are interested in debates, useless debates, irrelevant debates, debates that support government, nothing else. I'm not interested to support government, so I'm not agent of government. I represent people of this country. My master is public of this country, because I am born in this country, I am member of this country. I'm not servant to government, I'm not agent to government, I'm not interested in government. I'm interested in people of this country. I want to see this country rise, not government rise. Government is invested, government has its own interest. They don't care for people. That's also true. They are only interested in seats. They are only interested in power. Had government been interested in public welfare, they would have taken actions long back. Since March 2020, COVID entered our home. We did not care for that. And it also is much more intelligent than what we are. COVID-19 acted smartly, and they think it has gone. It had gone. Where did it go? They did not try to see. Maybe it might have disappeared somewhere momentarily, but it doesn't need your visa to come back. COVID-19 does not need government visa or public visa to come back. And it came back on its own. It's enjoying. People are burning, people are dead, and it's enjoying. And government says everything is okay, everything is fine. A period of 13 months is quite large in current age. They could establish factories of oxygen production. They could establish something. They could import cryogenic tankers. They could do whatever they want. Now they have exposed themselves to the whole world. People are going to help you. Every country is going to help you. And this is insult on yourself. That's such a big country that claims to be world teacher. We claim to be world teacher. We claim we are intellectual society. We have millions of engineers and doctors. Okay, doctors are doing that. What about engineers? No engineer is even interested in analyzing data that is provided by government. A country having millions of engineers, civil, electrical, mechanical particularly, whose grasping power is much higher analytically. We analyze in structures, in theory of structures, forces, actions. We can analyze every member. We can analyze whole structure. We have top analytical power, but we cannot analyze data given by government. We cannot even want to understand that and publish that, our comments. No, we don't want to tell people what our comments are. Such a coward community of this country of engineering. I can say, engineering community in this country is very coward. I don't know what's the reason behind that. I am seeing engineers busy on their own world, even though people are dying. They are busy in bending moment, shear force, structural engineering. They are always busy in that. They are not interested in it. They forget. If country people don't stay, your bending moment is useless. Where is your quality of thinking? What happened to your quality of thinking? Can't you think? Okay, a common man cannot think, common citizen cannot think, I agree. But a person like engineer cannot think. This is beyond imagination. Others are speaking, advocates. Other people are speaking because they know how to speak. But engineers are busy in bending moment and deflection, codes. They don't know how to come out of that. It's no meaning. Believe me, you have to speak. You may have your family members contracting COVID, then you will cry. Not now. That's what I'm saying. Situation of society itself is very bad. Situation of whole nation is very bad. And it's not going to finish in this month or next month. It's going to continue for 20 months, I can say to you. And I claim, based on my calculations, based on my understanding, which may be wrong, I'm not saying it may be right, but currently I say 20% on an average basis, 20% of population is in COVID danger. This means, say 25 to 30 crore people are under surveillance of, under control of, under grip of, under contract of COVID-19. Which situation demands we should be serious at this stage. We stop acting asleep in society and we try to perform. Time is there. Reliability must be there. Cost people are spending. Risk is there. Politicians are not public father and mother. Politicians are servants. They have forgotten that they are servants. They have started thinking they are kings of this nation. And even if they are kings of this nation, king has also public duty to serve public. King is not God. King has to serve people of this country. If these people think they have every right to say or lie, I think in that case we should kick them off. That's all. I don't expect prime minister or ministers speak lies, but they never speak truth. That's the problem. They think whatever they say people accept, then they think differently. Yes, first time, second time, third time people may believe you, but when people understand or people conceptualize that you are a liar, then they would stop thinking. Even if you speak truth, they consider that fake. And that's what's happening. People have stopped trusting television channels. People have stopped trusting official news. And according to them, they have to analyze themselves, but they say, oh, they're not saying what's happened. There was no control on personal protective equipment. Government never acted upon. And I still remember one complaint I wrote about for 8-9 months back, 10 months back to police in this state, Haryana, Faridabad, that I have seen people are not wearing masks, they are not complying with. And police called me itself, tell us who is not complying. What nonsense. You go and see, it's public. I just gave my observation, I just registered with you, and you are taking it as complaint. Complaint against whom? Go and see, people are not doing that. And today, if you don't ask them, you don't ask them for penalties or you don't take action against them, they would say there's no control, and this happened. I disputed with the hospital. Why are you calling me? I'll come to your home. It's not question of coming or not coming. You send your crew and see what's happening. In fact, police themselves do not use masks. That's also true, because most of them smoke, and while smoking you can't wear a mask. Well, I'm just giving you a reference that happened, but that's not my objective. My objective is completely different, because COVID-19 is friend of none. It's impact by nature. Of course, we say it's medical, but fact remains that till now, medicines or medical world has not revealed what COVID-19 is. No logical explanation has come what COVID-19 is, how it initiates and how it impacts us, and what's totality of COVID-19 is. I only consider size of the particle which is given by someone, that is equal to 0.0002 mm of the size, 0.0002, that's 10 to the power minus 4, 10 to the power minus 4, it's very small size, smaller than dust particle that's suspended in air. It's smaller, much smaller than that. If you take size of clay means it's chickeny mitti, and when it is dry, it converts to dust storm in wind, and that particle you cannot see. When collection of these billions of particle in here, you see dust storm, and that single particle is 0.0002 mm. It's like clay particle, and that particle can't be as an individual particle can't be viewed even through microscope. That is size of this. Even medical microscope whatever is used, that cannot be used to see this, and that's problem of this. We do not know how to do this. Is my general understanding as an engineer. I can say therefore this is very dangerous. It may not be, it's some root or no root, but we have no answer to that. We have no answer as scientists, as engineers. We can't explain that, and until we know what is there can be no treatment at all. Whatever treatment, whatever medicines, whatever injections and inoculations are being done, these are all having objective of providing or inculcating immunity into our bodies, and that's it. If we are immunized, if we have strength in our body, if we have resistance in our body, we can say we can resist impact of COVID-19. Therefore, my appeal to everybody is, it's in very bad state. You have to take your care, because we don't have that much infrastructural facility all over nation that can fetch for 2 million cases per day. That cannot fetch for 2 million cases per day. Now it is even reaching in remote areas which are called villages. It's not alone now, focused or centered in cities. And lockout also won't give any solution in this stage, because this is airborne, and when it is airborne, or you can say aerosols in covered area work fast. If you attend marriage parties, birthday parties, or some other celebratory functions, even on funerals and Kriya or Teremi or 13 days or whatever days, when you join something like that, you are undercover. Either go in open and do it, that you won't do. If you do undercover, if there is some aerosol at that place in air, it can impact upon everyone. And when you take food in some party, even there are 20, 30 people, they sit somewhere and eat and maybe talk, they remove their mask, then you know what happens. There are chances that you contract COVID. So better to avoid even marriages, to avoid other functions until there's compulsion. If there is death of some of relative, that's different. Otherwise, better to avoid marriages for time being, or better to participate in parties or functions. It's in your own interest, because once you have cavity contract COVID, you will then invite your family members also to have contract COVID. So that is my simple request, that it is a situation, worrisome situation. This situation we have to tackle with ourselves without any help from government. That situation is very, very, you can say, uneasy, and we should really worry about that. I will not take much now. I'll go to daily talk, because I am very concerned. I think a lot about this problem, and I don't like this. Engineer should be, schematic. Engineer should have some schedule. When we work on projects, we always either chart out schedule and follow that, or whatever schedule is given to project people, they follow it. We do our best to comply with that, because it is question of contract and contract data, contract duration. We cannot do beyond that. If we go beyond that, of course we don't die, but we have to pay damages, and that party, that owner who is owner of this project, that has to start that project, commission that project and bring it to use. But that person cannot do. So there's a delay on returns, and there's delay on occupation of that property, whatever we create through project to operation. We have to keep this in mind. Situation is of course worrisome. If this continues, there should be drawback in engineering. There will be no demand of engineering, because if people don't survive, if people don't stay, of course the population is there. We have no meaning of 1 crore people. Government think that way, or whole may think that way. If few crore people die, it's not going to harm this nation. But that is a nonsense statement, you can say. This is not human statement. You can't expect 25 crore people, 2 crore people, 1 crore people die, though already officially more than 200,000 people have gone. But that is official. It may be 10 lakhs, I can't say, because 3-4 times they issue lies. So this 200,000 which they say have gone, I may say it could be 800,000, it could be 500,000, it could be 1 million, it could be 1 million. Well, that's some imagination, imaginary hypothetical talk. But COVID-19 currently is going to cause harm to ourselves, and it's not only to ourselves but also to those countries who are worried, because COVID must be clear out of world. Also what happened in America, they say don't use masks. This is also another stupidity, I can say. Okay, might be you're feeling easy for COVID, but COVID is friend to none. COVID is a crooked, COVID is a clever entity. It goes to take cup of tea, I think takes recess and goes for a few days. It comes back again with fresh energy, recharged energy, you can say. When we take a cup of tea for some minutes, for some hour, we feel charged. And that's what COVID does. When it's tired, maybe it goes back to take some coffee or tea, for fresh soup, hot soup, and comes back. And we think it has gone. But it plays with love. So see, these foolish people, world foolish people think I have gone. I'm just resting. I just tried to sleep for 2 hours, then come back and attack you. That's what COVID is doing. We should be clear about that. Well, it's happening. What's happening, nobody can control. No one can control. There's no way we can control this. We control or don't control, nothing happens. Come back to engineering world. Civil engineering, construction engineering, design engineering, execution engineering, planning engineering, safety engineering, coordination engineering, communication engineering. We have to deal with all these in life. It's not simple engineering, I say. Social engineering it is, even in your own daily life. We deal with people, we coordinate with people, we communicate with them. And of course, computer world has changed everything. Communication is very fast, but coordination, I think, is not fast. There's a difference. There's a difference like communication and coordination. I read one post yesterday in which says, what is different between completion and finishing? What is difference between two? That writer is a question, because writer could not understand what is complete and what is finished. What is finished and what is complete? Can you understand that? I say this work is finished. All this work is complete. Is there any meaning? You think some difference? Finishing stays, or finishing, or finished, or complete. When somebody dies, we never say this person is complete. In Arabic world, they simply say finished. A job is terminated, he is finished. Generally, we use this word in the Arab world. If somebody is out of employment or terminated, it is okay, this is finished. What do they mean by that? Actually, they transmit like, because in those countries you have to work with visa, and when you are sent back, visa is finished, visa is cancelled, they got finished visa. Actually, there's a difference meaning. Finishing means a touch, a final touch. Finishing means now structure has been completed and it has been covered with something, so that structure is not seen. In our structural engineering we say finishing items, structural items and architectural items. Architectural items and finishing items are in same family, while structure is different. Structure can be called complete, structure can be called finished, but it doesn't mean building is finished. Structure is a part of architecture, architecture is a part of structure. Structure and architecture are related. Without structure, architectural is not possible, and without architectural, structure is not revealed. Both are related, but finishing is independent. Finishing is something that has to cover your architecture in all three dimensions: vertical, all three planes, you can say, not dimensions: vertical plane, horizontal plane, and diagonal plane. All. Something is complete means it's done. Something is complete means done, and finishing means it is over. It's finished. Complete means 100% complete. The finishing cannot be said 100%. That's the only difference. You can say it is your own interpretation, but we say in contracts, if you consider, in contracts, we never say finished. In contract world, we say complete. Contract is completed. This means nothing is left within certain definition. They don't say finishing date of contract, they say completion date of contract. So completion is more variable than finishes, because finishes is cover up. Completion is not cover up. Completion is cover up plus everything, secured. That's complete. Or activity wise, activity is complete. So completion is more important. Date of completion, date of practical completion, date of mechanical completion, and you can say final completion. So completion is better word if you think, which itself says totality. Totality, just like say compressive forces, we use press. See, when you say compression, com, and press. You press something with full uniformity, that's called compression. And same thing, if full uniform value is given, uniform specification is seen and applied on whole, it's called complete. A finishing is something else. So, just for reference I gave you, because I thought on that, because question is valuable, but complete is real word. Complete doesn't indicate depth, but finishing indicates something else. So complete or complex or complicated, we say so many complex are there. So we have to. So we may not say that one day COVID-19 is complete. You may not say that. That is something else. So we have to be clear about this. Engineering world is very wide, very vast. Civil, construction engineering, design engineering, and of course, because construction engineering in all disciplines, sub-disciplines, or you can say interaction of disciplines, interactivity, interdisciplines, inter-engineering disciplines. Civil engineering has got relations with mechanical engineering, with electrical engineering. Of course, it's a part of architecture, and architecture is part of structure, both. And it's got relations to electronics because of SCADA, because of CCTV, because of digital world, and also it has got relation to public in every way. Without civil can be nothing. You can say without civil there is no possibility under sky. Even if you have to go to WC, you need civil. Even if you have to take water, you need civil. When new child comes, whether in hospital or home, there must be some covered area so that baby can be delivered. So civil engineering is, you can say, human blood. Identification may be different, may be difficult, but civil engineering stays there. This point we have to understand very clearly, very well, if you respect civil engineering. People don't like to call civil engineers, they want to call themselves structural engineers. Well, that is, I think, a different kind of mindset. Engineering for people is important rather than you are a structural engineer or you are construction engineer or you are road engineer or whatever sort of engineer you are. That is your expertise. It doesn't. People have to see that way. People want sound, very strong, durable structures, and that's important. Your focus should be that. Rather, I am structural engineer, I am this engineer, or I am that engineer. Well, that's each individual has to see. Important is not your title. Important is your production, your performance. Performance, as I say, in quality list, I can say in quality list. Whenever you say what is that, no, we always say engineering means quality everywhere. When I say quality everywhere, it should be everywhere. It's not here or there. Everywhere. When I say quality of project, it should be on every members of project, on every component of project, every member of a structure, every discipline of architecture or others in that building or structure. Quality should be everywhere according to requirement, according to contract definitions, according to specifications. Quality must be available everywhere. And it's not only on projects, in life itself there should be quality. And it's very important to understand quality, because quality is not simple word. Quality is a title of systems, titles to individuals, titles to products, and titles to others. And when we say quality means, it means based on designs, whatever designs, structural designs or non-structural designs, architectural designs or conceptual designs, and whatever we think we should be or we should do, that's also designs or plot itself. And design also is taken in sometimes in negative terms. Oh, he designed this crime, he designed this plot, we say that. And that means all stages design. Designs for good, designs for bad. But in engineering world, we never think for design for bad, we only think for design for good. And that is construction. And when we use the word construction, it weighs heavily, because you have to combine various structures together, combination of structures, assembly of structures, and that's important. Artically, I am speaking this way. Construction, though it's considered by many, oh, it's a rough job, it's job like workers do it. It's not intellectual job, it's not intelligent job. Some people say that way unknowingly, or they do not understand what does construction mean. Quality, when we talk of this, means is high profile work. If you say it is quality work, if you tell some person who produced something, oh, you have produced very good quality, that person is very much complimented, because that work is quality based. If you don't compliment with quality, you say, okay, fine, you have done your job, that person won't be happy, because doing job and doing job with quality both have different meaning. If somebody tells me, oh, very good quality you are producing, certainly I feel pleased. If that's a fine, quality is restricted but your production is okay, it doesn't give me that happiness level, because I am hungry for quality. I am hungry for my senses, and my quality is my character. That is my identification, you can say. When you say branded product, what does it mean? It doesn't mean that we like that brand. It means it is expected that branded project must be inculcated with quality, must be inserted with full quality. That's the only difference. We say, oh no, this is locally produced. We consider, okay, this may not be having quality. That is our mindset. Though sometimes local production is more better in quality if you compare it to branded project. But this is not very common. And many branded companies just buy this material, or they subcontract this material to those local people who just produce it and deliver to these companies just to put their seals on. And that's what happens in many cases. Generally it happens. So you cannot say that brand means quality. I say brand is just trusted name, and that's it, nothing else. just a trusted name. Because when there is brand, you may say, oh, this is very big organization, must have all structures, and they must have trained staff and technicians, and they must have certain established procedures of quality, they must have certain systems, and they must be complying with that system. And when we comply with the system, of course brand would bring quality, and that is what is understood. It's not that this is true, it's understood because of trust. Yes, I cannot say all branded products are not quality based, but in general you say nowadays there are so many brands you can't even guarantee, and that's why we are cheated every day. In name of quality they are selling their product, not in name of values. They say, okay, we will give you warranty and guarantee, don't worry, for 1 year, 2 year, 3 years you are tension free, but after that what do they charge? Half product charge is consumed, is half product cost is charged as AMC or manual maintenance contract, annual maintenance contract. So there they earn that. Actually this is indirect scheme of business. For 2 years or 3 years you give quality, or quality means you are responsible for its maintenance free of cost, but that cost is also included in the price of product. We should not miss that point. When they say warranty, it doesn't mean free, they charge in cost of that product. That's also true. And after warranty is over, they would say, okay, warranty is over, and we disclaim, so you have to pay more if you want our services to continue it with maintenance. And it's where the business lies in. If you buy a product for X amount, and then its annual maintenance contract will be nearly half X, 0.5X or 0.4X, just take on average 0.5X, and if you have 5 years, so they would charge you 2.5X. This means in that 5 years period, or you can say 6 years period, you have to pay X amount plus 2.5X, which is 3.5X. So 3.5X you pay in a period of 6 years. So how much expensive this material for you is, and then you have to buy it again. So they charge you indirectly, which we do not calculate, because it's okay for 5 years. I am at least with peace for 5 years plus 2 years warranty, and then we will see what happens. If you have to buy more, we have to buy more. We have to buy new, we have to buy new. This is mindset. So this psychology they have caused in people, and we trust that, and we accept that as well. This is a call of criminal design or commercial design, how to sell you. These salespeople have caused this type of design. Means truth is being, you can say not truth, fake, false word is being sold in name of brand, in name of quality. So this means this quality does not exist everywhere. This exists only in designs. They sell you something without quality, because if it is only for 2 years, for a product for 10 years, then where's quality? If I am given assurance that this product will work for 2 years free of cost and 8 years I have to pay, where is quality? Means there is only 20% quality, 80% quality is missing, and if you want that 80% quality work, you have to pay more, 3.5x amount. That's different. It's question. So where is system then? System is also based on that. They would say, yes, we will give you, this is our procedure, and you know our procedure, this is what customer satisfaction we can provide you with. This is customer satisfaction they can provide me with. And they say, yes, it is customer satisfaction, and as a customer I am forced to accept that. There is no other way out. Really very much surprising it is. And as an individual I have nothing to do, I can't do anything. They may say, okay, don't buy this. See, there will logic. Okay, you miss, don't buy this, condemn this. Means I am not able to condemn because I can't produce that, and this is my problem, that I can't produce that. They get use of, they get benefit of. System quality is in the hands of manufacturer, is in the hands of organization. They can define whatever they want within there, and we never ask for details of that. I have not seen people ask for details. If there's a system, there's a quality manual of some company, or there's a system of quality they enjoy, they will write in such a way that common customer cannot understand. If I want to understand, maybe because I am an engineer, I may understand. But if a person who has no background of this system explanation, that person cannot, oh, this is so thick book, I can't read this, I'm sorry, you just tell me what is in this. And they will tell you, don't worry, this is customer satisfaction. Our policy is customer satisfaction. Customer satisfaction is number one. Another way, when you call for service from any AMC company, they will just give you half an hour service or 10-minute service for some product, and they say take your signature also. Then they will call you, tell us how our service was. I don't know why. This is a part of quality. Your statement is very important. Your response is very important. Even on telephone services you will find that. Oh, you are calling us and your call is very important to us. You are just giving me service. I am paying you for that. Then why you want to get my comments on that? But this is everybody doing. Okay, my technicians visited you and there was a complaint, he repaired that. We want to know how was that service. If you say good, excellent, they'll say, do you want to tell others? Do you want to recommend to others? Or you want to post this on Facebook? Or you want to post it? But what does it mean? Am I advertiser? I am paying you money for AMC. I am buying your product. I buy it. I pay for repairs. Then why should I recommend this product on your behalf to someone? You are not doing any obligation on me. I pay you, you pay your service. That's it. Why should I post on Facebook? But because we don't want to harm relations. Everybody knows this all fake, this all drama. Even if I post on Facebook, it doesn't mean people will trust that. But system they have made like this, they put you behind, they charge money, they deal with your quality, but they force you to help them. This is called, you can say, kind of organized crime, I can say. I have to spend time on that, maybe 10 minutes. Why should I spend my time? Another point is system, how they make. Every day you receive calls on phones. I am calling from there, I am calling from there, are you this, are you that, good morning, good evening, good afternoon. Oh bloody hell, I am waiting for your phone. I am not waiting for your phone. My phone is not for that purpose. My phone is for my use. Why should I respond unto you? This is a question mark. If I get 20 calls a day, 30 calls a day, these Airtel company or other companies, they provide lists of telephones to everyone on payment basis. And they just automatize this and call you every time. Maybe you are in cremation ground or you are somewhere else. You are in serious mood. You are concentrating on some work. You have to respond to them. Oh, fuck off, I can say. I don't listen to you. I'm not sitting here for you. Sometimes I feel very angry. Who are you to call me? Did you ask me to call? I did not permit you. Why are you disturbing me? Means this is a kind of nonsense. They have got right to call you anytime. This is what I say. This is a crime. Crime against society. Why should you call me for what? Send your representative to talk to me. If I want to buy this, I will buy this. If you don't, you have to spend money on that. If you want to sit in office, give some charge to some female or male. Okay, you call every day so many people, and maybe out of that you get 5 to 10% response, and your business is done. So you are just sitting doing nothing. You want to get business. This is very bad tendency it is. Where is quality there? You are selling your product without any effort, without meeting people, without showing you, and you say you are done. Means we have to see where is quality. Even you buy something online, you have no opportunity to inspect that item. And sometimes when you go to market, you want to buy something, that would say, okay, this is product. You see this online, you see on website. I can't explain to you. If you're happy you buy it, I'll give you packed one. I won't give you. I want to open seal and show to you. This is in box, you go and see. And that person won't explain anything. Where is quality then? There should be quality in sales itself. Salesperson should explain to you what do you want. Where is quality everywhere? Means I have to buy some material based on online explanation or just on photograph. Then if it doesn't work, I have to keep fighting with them. They will replace that again with something else. What does it mean? Well, I don't know what I'm going to buy. Nobody can demonstrate to me. After I buy, person comes and installs and explains something. At that time, everything has gone out of my control. That's why I say sales design are not quality oriented. Purchaser, who should be called a consumer, should be called a king, is no more a king but a forced person. A person with force that you have to do it if you want to buy it. Otherwise, you sit down, don't buy it. Moreover, they say, oh, you have discounted you discount. We give you warranty. Warranty is also a support then. You are giving me warranty, you are doing an obligation on me, you are charging for that. If you charge for that, what do you give me? Your warranty price is included in sales price. In manufacturing, MRP, what do you give me then? Nothing. And then you charge on AMC. So your business is profit-related. It's thriving because of my money. So this is a commercial design. Then you can say, look, what I'm trying to say is, system means this rubbish one. They would write all this in system, and because they write, they comply with that. You say we are following our procedures, we are following it up with our quality system, and this is meaning of customer satisfaction. We satisfy customer like this. Means customer satisfaction is you have to spend time as customer, as consumer, for that company's promotion. Though there is not defined promotion, but this actual promotion. During AMC it is promotion, during White's promotion, they will ask you many times, write, please help us online, write comments about this, write comments about that. Suppose you have 10 items and everyone asks you, means am I working for you? Do I work for you? I don't work for you. So there are so many points we have to understand. Society is being cheated by these people. They make profit, but you waste your time for them. Why? I paid you, finish, get lost. So this is what they means. They say they are performing. Product performs. No, this is not product performs. My payment performs. I paid to you. You are not returning me full. So your performance is not imperative. It is negative. It's negative. And if there happens, there's suppose two items in one work, for example, there's one inverter and other one is battery. Inverter guy is never takes any responsibility for battery, and battery guy cannot take responsibility for inverter. In beginning, nothing, no problem, you are new, inverter and your battery both are new, nothing happens. But when time comes for a maintenance and they say, if you call inverter people, will say, no, there's a battery problem. If you call battery people, no, there's an inverter problem. It's just an example I'm giving. It happens. They will not take combined responsibility. They won't take application responsibility. When I say application, here is question of application, and that application is very important because I want engineering input on inverter. I want alternative arrangement for my electrical supply because main supply is off. That is my application. Application is that use of inverter provides me some power. But that application is based on battery and inverter. You call the UPS and battery. My application is not over by one vendor. I have to be in contact with two vendors, battery vendor and inverter, because nobody takes combined responsibility. So that's the point. Where I am defeated, these two vendors enjoy. I am defeated. There's no application warranty. It happens in many cases, not in one case. But engineering says application is important. It must be affected, and that is called engineering. If there is no application, there is no engineering. I can't call it engineering. So this means there is no professionalism, but they talk of profession. They say no, we have thought a lot and we are giving you reliability service, and that reliability, which should be safety plus service plus durability and other areas based on complete analysis, it doesn't exist. It doesn't exist. That's where drawback lies in. Even if you are being cost, risk you want to cover, reliability you want to achieve, but none of these work, only cost works. You have to pay for everything. This is you can say world today. Quality is only for display. Quality is only a showroom, not more than a showroom. It's design only. In fact, this method statement which I am saying, which is basis of everything, this quality system, if you consider method statement, they will not give you any loophole. Business is business, and because you are very small customer, they may have millions of customers or lakhs of customers. They don't bother you. They bother you only to that percentage. Maybe you are 1 over 1 million or 1 over 10,000. So you only get that fraction of value, and whole value goes to that organization. That is my point, what I wanted to say about this explanation, because every time you have to think differently and explain, just like it's happening in hospitals these of COVID-19. Beds are not available, gas is not available, people are there, they are not valued, they are not cared for, and this was deterioration situation is arise. If you have medical claims, hospitals are not allowing entry to you. So these medical claims people are of course free. They are free. What can they do? Even if you die, they won't pay you because there is no paper backup to pay you. You are not admitted and they won't pay you. So what is this? You understand what I am saying? This situation of COVID-19 has gone to such level that you won't be allowed admission. You won't be allowed admission. Maybe they have some understanding with these companies. Maybe, who knows? Don't allow admission. If you don't allow admission, what shall happen? You won't be given any treatment, and even if you die, there will be no liability on anybody. You can't make claims. You can't raise any claim because you are not admitted. You are not hospitalized. So where is your claim? This claim lies with that company who is your Mediclaim organization. You are gone, they save money, right? This is a worrisome situation. There should be proper infrastructure, but there is not. This means our nation did not want that we should have infrastructure. This means is that. I'm just giving a reference. So my concern is about method statements, which actually is required to achieve quality, and without which quality is not possible. Now, not to go far away, I think I have taken enough time in this explanation of quality, and I think it's important one, very important one. I was talking about yesterday about supplementary cementing materials. We talked a lot in that, and now accelerators we talked, fly ash we talked, and autogenous temperatures, let us say which one, slump and workability we are building we talked, and setting time, mechanical properties, stun development, Young's model plasticity, during shrinkage, FP. Yes, GGBS, let us say, I think I did not continue this one, right? Let me see, how could I, maybe I remember. Okay, let us talk GGBS now, later. We'll talk again on this because this is a very important issue. Very important issue. Let me use this one a little. Let's go back a little. I think I should not run away like this. Let us say drying shrinkage. Before that, Young's model was elasticity. What it was? Strength level, mechanical properties. Okay, let us read it and go back. What's bleeding? It says of fly ash. Bleeding of fly ash concrete depends on manner in which fly ash is used. When fly ash is used as a direct replacement for cement with no say reduction, with no reduction in water content. Bleeding of fly ash concrete depends on manner in which fly ash is used. When fly ash is used as a direct replacement, when fly ash is used as a direct replacement for cement with no reduction in water content, bleed water of fly ash concrete generally increases. However, when a reduction of water due to use of fly ash as a replacement of cement in concrete is made, reduction of water, to maintain similar workability, bleed water of resulting fly ash concrete is generally lower than that of concrete made without fly ash. High volume fly ash concrete at low unit water content does not bleed high volume fly ash. This generally creates a problem for those people who work on finishing of surface or flat work surfaces. You can say this creates a problem for those masons, you may say finishers of flat work surfaces, who are used to work with more bleed water at surface during finishing. As with some concrete, particularly with a low water to cementitious material ratio, care is required to prevent plastic shrinkage, cracking at surface immediately after placing concrete by following required measures on hot weather concreting. Plastic cracking occurs when rate of evaporation of concrete surface exceeds rate at which bleed water replenishes water at surface. Autogenous temperature rise. The use of low calcium fly ash as partial replacement of Portland cement is in concrete shall generally contribute to reducing temperature rise in concrete compared to Portland cement concrete. This is too important an application in massive block concrete to reduce potential for cracking associated with excessive thermal gradients. High calcium fly ashes, depending on total alkali content, may increase temperature rise. High calcium fly ashes, depending on total alkali content, may increase temperature rise. For similar 28 days compressive strength and workability, settling time of fly ash concrete may be longer than normal Portland cement concrete for a given combination of cement and chemical admixtures. It says for similar 28 days compressive strength and workability attainment, setting time of fly ash concrete may be longer than normal Portland cement concrete for a given combination of cement and chemical admixture. This may influence schedule for finishing horizontal surfaces, particularly at high levels of replacement if it is more than 30% and or in cool weather. In this case, using a doses of water reducer in lower limit of range proposed by manufacturer can contribute at decreasing to some extent initial setting time of fly ash concrete. However, this should not be conducted at expense of strength development and durability of concrete. Still, in hot weather conditions, extended setting time can be beneficial. Concrete accelerators may be used to offset increase in setting time when using fly ash. Now mechanical properties. Strength development. Strength development of fly ash. Strength development of fly ash concrete is strongly affected by type of fly ash and curing temperature. Strength development of fly ash concrete is strongly affected by type of fly ash and curing temperature. Use of low calcium fly ashes. Low calcium fly ashes generally decreases compressive strength of concrete at early ages up to 28 days and increases it at later ages due to pozzolanic reaction of fly ash when compared to Portland cement concrete with similar 28 days compressive strength. On other hand, use of high calcium content has a marginal effect on strength development. In cool weather, low temperature generally slows down chemical reaction between cement and water and therefore strength development of concrete. For fly ash concrete, this effect is more pronounced due to reduced Portland cement in mixture and greater dependence on pozzolanic reaction on temperature. However, concrete with fly ash can be proportioned to achieve similar one-day strength as Portland cement concrete mixture by judicious proportioning of mixture. This usually requires a reduction in water to cementitious materials ratio, that is W/cm, a reduction being greater with high level of supplementary cementing materials. It should be noted that reduction in strength might not be as pronounced in precast concrete where heat curing is used. Reduction in early ages strength can also be partially compensated for by incorporating silica fume. Reduction in early age strength can also be partially compensated for by incorporating silica fume with fly ash to produce a ternary blended cement or by using suitable accelerators. Young modulus of elasticity. Since modulus of elasticity of concrete is related to its compressive strength, in general, effect of fly ash on elastic modulus of concrete is similar to effect of fly ash on strength development. Therefore, elastic modulus of fly ash concrete is generally lower at early ages. Elastic modulus of fly ash concrete is generally lower at early stages and higher at later ages than that of concrete made without fly ash and having similar 28 days compressive strength. This means elastic modulus of fly ash concrete is lower at early ages, you can say 28 days age, and higher at later stage than that of concrete made without fly ash and having similar 28-day compressive strength. Drying shrinkage. Effect of fly ash. I'm feeling thirsty, I think. Just a minute, please. Let me take some water. I'm feeling thirsty. Effect of fly ash on drying shrinkage is highly dependent on how concrete is proportioned. Drying shrinkage. Effect of fly ash on drying shrinkage is highly dependent on how concrete is proportioned. If full advantage is taken of reduced water demand, and unit water content is reduced, and if water cement ratio is also reduced to achieve strength parity at 28 days, fly ash concrete shall have significantly reduced shrinkage compared to Portland cement concrete. If full advantage is taken of reduced water demand and unit water content is reduced, if water cement ratio is also reduced to achieve strength parity at 28 days, fly ash concrete shall have significantly reduced shrinkage compared to Portland cement concrete. Impact of fly ash on drying shrinkage also depends on maturity of concrete when drying commences. If drying starts at 1 day, fly ash concrete may shrink more. Hence, importance of proper curing of fly ash concrete is envisaged. Creep. Effect of fly ash on creep. Effect of fly ash on creep is mainly related to impact that fly ash has on ultimate strength of concrete. Since fly ash increases ultimate strength of concrete due to pozzolanic reaction, creep of fly ash concrete is generally lower than that of Portland cement concrete with similar 28-day compressive strength. Fly ash increases ultimate strength of concrete due to pozzolanic reaction. You know what is pozzolanic reaction. Creep of fly ash concrete is generally lower than that of pozzolanic cement concrete with similar 28 days compressive strength. However, if fly ash concrete is loaded at an early age, creep may be higher. Durability. I think you know what is pozzolanic action. We may have a little discussion on that, but let me see if I can find something. Maybe may not be. Pozzolanic action is a long-term reaction which involves dissolved silicious acid water and CaO or CaOH2 other pozzolans to form a strong cementation matrix. This process is often irreversible. Sufficient amount of free calcium, iron and high pH of 12 and FO is needed. Pozzolanic reaction overview, let me see. I go to chemical reactions. Just a minute, let us see what happens. What does it mean? It's better sometimes to see. Just for refreshing knowledge, it's also important. Modern approaches in material science, chemical reaction pozzolanic concrete. Let us see what it says. I will show you also this better. If you can see this, just for reference only, not for records. I'll just show you something. Let me print out and give it to you. PHP, print out, print. Okay. So I think I got print out here. This must be somewhere here. Let us see what it says. Let me go through this and see what this you mean by that. It's some material. We'll just read this one better, I think. So anytime we can see this. let us talk on this, and I close other files, otherwise I may find problems, let me see which files are open so that I can close those unnecessary files here. I'll close this and come on to talk to you of this. This is also, there's no meaning of this PHP, so I'll depend on this now. Let us see this. Okay, it is which site? Chemical reactions in concrete, and whatever it is, you can see yourself, modern approaches, and it says cement is most utilized construction material and second most consumed commodity. Cement is most utilized construction material and second most consumed commodity in world after water. Its demand has soared proportionally with exponential rise in population in a bid to match required development. Heavy energy intensive processes that are involved in its production contribute to about 7 to 10% of total global emissions, with potentially adverse environmental implications, and are also economically expensive. These processes and generally those of production of concrete consume heavily on natural resources such as sand, gravel, water, coal, and crushed rock, mining of which mars environment. It is, however, possible that energy and cost efficiency can be achieved by reducing on amount of clinker and in its place utilizing supplementary cementitious materials, SCMs or pozzolanas. Supplementary cementing materials, SCMs or pozzolanas, that require less process heating and emit fewer levels of carbon dioxide. This paper elaborates on different types of chemical reactions taking place in concrete containing pozzolanas as a partial cement replacement. Pozzolanic material relies on secondary reaction following hydration of cement, whereby it reacts with free calcium hydroxide. COH to form calcium silicate hydrates, CSH, calcium silicate hydrates. Phase which is major contributor to strength in concrete, CSH, calcium silicate hydrate. Phase which is major contributor to strength in concrete. As a result, there is usually long-term strength development up to and beyond 91 days in pozzolanic concrete. This is very important. A pozzolanic material relies on secondary reaction following hydration of cement, whereby it reacts with free calcium hydroxide to form a calcium silicate hydrate, that is CSH, calcium silicate hydrate. Phase which is major contributor to strength in concrete. As a result, there is usually long-term strength development up to and beyond 91 days in pozzolanic concrete. Due to depleted levels of calcium hydroxide, pozzolanic concrete imparts superior sulfate resistance. In this hydration of cement, pozzolanas, etc. are important one. It says it is reported in literature that apart from environmental friendliness, use of supplementary cementitious materials such as pulverized fuel ash, PFA, ground granulated blast furnace slag, GGBS, silica fumes, SF, metakaolin MK, and rice husk ash, RHA, rice husk ash, reduces cost of concrete and improves durability of hardened concrete, thereby enhancing service life of structure. This focuses on chemical reactions which happen in pozzolanic concrete, that is concrete containing PFA, SF Mk and RHA. Cement is deemed to have considerable high Cement is deemed to have a considerably high carbon footprint, contributing immensely to global anthropogenic. Cement is deemed to have a considerably high carbon footprint, contributing immensely to global anthropogenic carbon dioxide. Climate change is purported to be a phenomenon that can bring about a rise in global temperature due to presence of excessive carbon dioxide in atmosphere and is cumulative and irreversible over time scales of centuries. Burning of fossil fuels, in this case for production of cement, contributes to greenhouse gas effect, which is a major cause of climate change. Even though heavily energy intensive, cement is pivotal to development and is produced in virtually all countries. 1 ton of concrete on an average is produced every year. 1 ton of concrete on an average is produced every year for each human being in world. 1 ton of concrete. 1 ton of concrete means what? Concrete is 2.5 tons per cubic meter. This means 40% of 1 cubic meter concrete. 1 ton of concrete on average is produced every year for each human being in world. A population that currently stands around 7 billion or 8 billion, growing population matched by a corresponding increase in demand for socio-economic infrastructure that is aimed at creating sub-affluent society, especially in developing world and former socialite countries, has led to a gradual increase in demand for cement in past few decades, with construction investment directly linked to higher gross domestic product (GDP). Cement was described by Salami and Salim as most utilized construction material in world. Its global consumption only seconding that of water. It constitutes between 7 to 15% of total mass of concrete mixes. Yet, according to Sakai and Noguchi, development of a nation is directly proportional to its consumption of concrete. Its yearly global production is approximately 2 billion tons. Yearly global production is approximately 2 billion tons, accounting for about 7 to 10% of total global carbon dioxide loading in atmosphere, a considerably high level of emissions when compared to 2% total global carbon dioxide emissions attributed to aviation industry. Production of a ton of cement emits approximately a corresponding ton of carbon dioxide, making it most energy intensive material produced after steel and aluminium. Energy intensive material produced after steel and aluminium. Cement section elaborates on production process. Inasmuch as development is required to match increasing populations, it should also be sustainable. This principle of sustainability lies in appropriate balance of economic, social and environmental impacts. Still defined sustainability as a road for society advance in which progress must be in harmony with natural world rather than in conflict with it. While Gambhir termed it as a regime in which endeavors are towards meeting needs of present generation without compromising those of future generations, with a heavy demand for concrete in developing world and other major and equally populous economies such as China and India predicted, cement producing companies have not anticipated in foreseeable future any major changes in production that will reduce on emissions. However, energy efficiency can be achieved by reducing on amount of clinker and utilizing SCMs, which require less process heating and emit fewer levels of carbon dioxide. Now there's some table that shows something. It shows embodied carbon dioxide for both PFA, also fly ash, and GGBS is substantially less than CEM. Industry and agricultural waste products such as PFA, GGBS, RHA, and CCA unnecessarily occupy space when stored or create environmental hazards when dumped in landfill. The utilization in construction industry reduces overall cost of construction, mitigates on technical and environmental nuisance that's associated with production of cement, reduces solid waste, cuts greenhouse gas emissions, and conserves existing natural resources, thereby enhancing sustainability as well as improving properties of fresh and hard concrete. Now, concrete is a predominant material used in construction worldwide and widely used in all types of civil engineering works, including infrastructure, buildings, housing, hospitals, and environment protection. Concrete is usually a mixture of cement, powder, water, sand, fine sands, and gravel. Coarse aggregate proportions of each ingredient's constituents are adjusted to produce a well-balanced concrete. Concrete is a versatile material and important properties such as strength, durability, versatility, affordability, and fire resistance with thermal mass. Furthermore, it's locally produced and utilized in all countries. Most common type of cement, which is used in combination with other materials to form a different type of concrete, is Portland cement. Portland cement is produced by burning a mixture of calcium carbonate, that's called limestone, or chalk, calcium carbonate, and an aluminosilicate, that's clay or shale, so silicate, aluminosilicate, clay or shale, and then product is ground with approximately 5% gypsum to produce cement. Cement is a material which binds together solid bodies, aggregate by hardening from a plastic state. European standard specifies, okay, leave it now. This is cement type 1, type 2, these are all that. European standard specification EN197 categorizes cement generally available in Europe in 5 main types: type 1 cement 1, type 2 cement 2, type 3 cement, like that. Type 1, it says Portland cement containing 5% of secondary sand, Portland cement containing 5% of secondary sand, supplementary constituents. Type 2 or CEM, Portland composite cement up to 35% of other ingredients other than OPC, that is PFA or limestone. Cement type 3, CM3, blast furnace cement, comprising Portland cement and higher percentages of blast furnace slag than in CEM. Cement type 4, cement 4, pozzolanic cement includes Portland cement and greater portions of pozzolana than CEM cement 2. Then cement type 4, composite cement, mix of Portland cement and combination of blast furnace slag, fly ash, and pozzolana. So these are 5-1. Cement 1 is just containing 5% secondary sand. Then cement 2, Portland comprises 35% ingredients other than OPC, and that's type 2. Type 3 is blast furnace slag cement, comprising Portland cement and higher percentages of blast furnace. Then CM2, CEM this is. Then CM4, pozzolanic cement, includes Portland cement and greater proportions of pozzolana than cement 2, and also cement type 5, composite cement, mix of Portland cement and combinations of blast furnace slag, fly ash, and pozzolana. In United Kingdom, concrete is specified using BSEN 197 cement composition specifications and conformity criteria for common cements. Now, manufacture of cement is an energy intensive process Manufacture of cement is an energy intensive process. First steps to quarry main raw material such as limestone, clay and other materials. After quarrying, rock is crushed. After quarrying, rock is crushed in different stages. First crushing reduces rock to a maximum size of about 15 centimeter, and secondary crusher or hammer mills reduces rock size to about 7.5 centimeter or smaller. A mixture of crusher rock and other ingredients such as iron ore or fly ash and ground. A mixture of crushed rock and other ingredients such as iron ore or fly ash and ground is fed into a cement kiln. Cement kiln is heated to 1400 to 1600 degrees Celsius in large cylindrical steel rotary kilns lined with special fire bricks. Kilns are about 365 centimeter in diameter and large enough to accommodate an automobile. Large kilns are mounted with axis inclined slightly from horizontal. Fine ground raw material is fed into higher end of kiln, and at lower end is a powerful blast of flame produced by burning coal, oil, fuel or gas. Certain elements of material that moves through kiln are driven off in form of gases, and remaining materials that emerge from it as grey balls are known as clinker. During manufacturing process, large amounts of carbon dioxide gas is emitted. Hence, given this is an energy intensive process, production of cement has a very high embodiment or high embodied carbon dioxide. Clinker is then cooled and ground to fine powder in a tube or ball mill. Ball mill is a rotating drum filled with steel balls of different sizes depending on desired fineness of cement that crush and grind clinker. Gypsum is added during grinding process to provide means for controlling setting time of cement. Cement is then bagged and transported for concrete production. According to Taylor, at mixing phase, some specification allows for addition of other materials. Then you can say there are four main chemical compounds present in Portland cement whose proportions in mix affect properties of resulting cement. These compounds are tricalcium silicate. You must have heard of this in tricalcium silicate, dicalcium silicate, tricalcium aluminate and tetracalcium aluminoferrite. Again I say tricalcium silicate, dicalcium silicate, tricalcium aluminate and tetracalcium aluminoferrite, and its properties are shown in table now. Typical composition of Portland cement, so that's a different one. Now tricalcium silicate, it says water reacts rapidly with tricalcium silicate, that is C3S, tricalcium silicate, to produce a large amount of heat, exothermic reaction to form calcium silicate hydrates. Calcium silicate hydrates. It has high strength and contributes most to early strength of cement hydrates. Dicalcium silicate, C2S. Water reacts slower with C2S to form calcium silicate hydrates. Due to slow rate of reaction, whatever heat developed is dissipated before sufficient temperature rise occurs. Tricalcium aluminate, C3A. Water reacts very rapidly with C3A by developing a significant amount of heat and with a very rapid set. This reaction is retarded by addition of gypsum during grinding stage to prevent flash setting. Very important point. Water reacts very rapidly with C3A tricalcium aluminate by developing a significant amount of heat and with a very rapid set. This reaction is retarded by addition of gypsum during grinding stage, that is to prevent flash setting. Tetracalcium aluminoferrite C4AF aluminoferrite. Water reacts rapidly with C4AF. However, reaction doesn't produce much heat with minimal contribution to strength. Therefore, hydration of C3S and C2S are main exothermic reactions, a chemical reaction that releases heat. Water has an effective impact on workability of concrete and thus on water cement ratio. On one hand, using a low water cement ratio shall lead to better strength and higher durability. However, low water cement ratio may result in difficulties in handling and working with concrete mix. Workability of concrete can be enhanced by using superplasticizers. It is important that water is relatively pure. Seawater must not be used as high salt content can induce rapid chloride attack in reinforced concrete. When Portland cement is mixed with water, it reacts and its constituent compounds undergo a series of chemical reactions that are responsible for hardening of concrete. This process is called hydration of cement. Specifically, as previously mentioned, water reacts with tricalcium silicate and dicalcium silicate, most reactive compounds. During this first reaction, cement, calcium silicate react chemically with water to produce a hard paste gel that coats aggregate made up of calcium silicate hydrates phase, which is major contributor to strength of concrete. First reaction involves tricalcium silicate, and that is tricalcium silicate plus water. Calcium silicate hydrate, result is calcium silicate hydrate plus calcium hydroxide lime, that is calcium hydroxide plus heat. So it is 2Ca3SiO5 plus 7H2O, that gives to 3CaO, 2SiO2, 4H2O plus 3CaO bracket OH2 heat. This is often written in shorthand from as follows in most civil engineering and construction literature, that is 2C3S plus 6H2O, that gives C3H2H3 plus 3COH plus heat. Initial reaction also involves dicalcium silicate. Dicalcium silicate plus water, calcium silicate hydrate plus calcium hydroxide plus heat. 2Ca, 2SiO4 plus 5H2O, that goes to 3CaO, 2SiO2, 4H2O plus COH2 plus heat, and also often written in shorthand form as follows: 2C2S, 4H2O, C3H2HS plus H8 plus COH2 plus heat. During hydration of cement, there is also formation of lime. During hydration of cement, there is also formation of lime, calcium hydroxide. Both reactions are exothermic, which means that heat is released during reaction process. Tricalcium silicate and dicalcium silicate are main contributors to compressive strength in concrete tricalcium silicate and dicalcium silicate are main contributors to compressive strength in concrete. According to Darwin, when tricalcium silicate is first mixed with water, for first 15 minutes a rapid evolution of heat occurs known as stage 1. Then for next 2 to 4 hours follows a relative inactivity known as induction, dormant period. Then for next 2 to 4 hours follows a relative inactivity known as induction, dormant period. Portland cement concrete remains in plastic state for several hours due to this prolonged phase of inactivity. At end of induction period, tricalcium silicate continues to rapidly hydrate, and by 4 to 8 hours it reaches its maximum rate of heat evolution. This phase is acceleration period or stage 3. After 8 hours, early hardening has begun, and during stage 4, rate of reaction slows down again. Within 18 to 36 hours, it reaches steady state or stage 5. So it's important, of course, observation. Let us read it again. I come back in some time. You can read it. It's important one. If you can read it, I think I'll again come and see this. Give me some minutes. I go and come back. Okay, gentlemen, sorry, I was running late. So I was just talking of this issue of during. Now it's very interesting one here. Hydration of cement. It's very interesting statement here. Formation of lime, that is hydration of cement and water. Formation of lime, that is calcium hydroxide, COH, C2H. Both reactions are exothermic, which means that heat is released during reaction process. Heat is released during reaction process. Now tricalcium silicate and dicalcium silicate are main contributors. Tricalcium silicate and dicalcium silicate are main contributors for compressive strength. According to whatever you see Darwin, when tricalcium silicate is first mixed with water, let us say water and tricalcium silicate are mixed together for 15 minutes, tricalcium silicate and water combine. First 15 minutes rapid evolution of heat occurs, known as stage 1. In 15 minutes, you can say tricalcium silicate and water evolves heat of stage 1. Then for next 2 to 4 hours, means after 15 minutes, next 2 to 4 hours follows a relative inactivity known as induction, dormant period, stage 2. 2 to 4 hours, you means unknown, or you can say known as induction, dormant period, stage 2. Portland cement in plastic state after 15 minutes or 4 hours, 2 to 4 hours. Portland cement concrete remains in plastic state for several hours. Due to this prolonged phase of inactivity, at end of induction period, tricalcium silicate continues to rapidly hydrate. That is, tricalcium silicate continues to rapidly hydrate, and by 4 to 8 hours it reaches its maximum rate of heat evolution. It reaches maximum rate of heat evolution. This phase is acceleration period of stage 3, that is 4 to 8 hours, means when it makes maximum rate of evolution. This phase is acceleration period. After 8 hours, early hardening has begun, and during stage 4, rate of reaction slows down again. Within 18 to 36 hours, it reaches its steady state of stage 5 below shows. Okay, so then comes off shows rate of heat evolution. Now dicalcium silicate hydrates in same way, but because it is less reactive compound, rate of reaction is lower. During hydration, tricalciums eliminate, reacts with sulfate ions that are found in gypsum to form calcium sulfoaluminate hydrate, commonly called ettringite. Calcium sulfoaluminate hydrate, commonly called ettringite. If sulfate is all consumed before C3A has completely hydrated, then ettringite transforms to another calcium sulfoaluminate hydrate containing less sulfate, called tetra calcium aluminate monosulfate 12 hydrate, or otherwise known as monosulfoaluminate oil. Now I will not go to further details because that is not objective of this talk. You can see that 2C3A plus 6H2O, it goes to 2C3AH6. Ettringite does not contribute to compressive strength. Ettingite does not contribute to compressive strength because of sulfate environment. According to other researchers, during hydration, tetracalcium aluminoferrite with or without gypsum forms similar hydration products to tricalcium aluminate, but reactions are slower and require less heat. Concrete containing 100% cement usually reaches its maximum strength within 28 days. Hence, this is usually taken as reference point for most projects using concrete. That is, most SCMs, most supplementary cementing materials are pozzolans. Pozzolanas, however, it's important to differentiate between a direct cement replacement and a pozzolana. A direct cement replacement is a type of cement substitute that can replace Portland cement without requiring a pozzolanic activity. Reaction discussed below. Now, most common type of these replacements is ground granulated blast furnace slag, GGBS, which is a byproduct of iron and steel industry. Is a fine white powder. GGBS is chemically very similar to cement, so you can directly replace cement by up to 90% in some structural concrete. However, it's gone. Yes. However, 90. Yeah. Most common replacement is between 30 to 70%. Reactions between Portland cement, GGBS and water are complex. Portland cement reacts first with water by forming insoluble hydration products such as calcium silicate hydrate, and same time it forms a more soluble product, calcium hydroxide, which migrates through pore solution. That is calcium hydroxide which migrates through pore solution. GGBS reacts with excess free calcium hydroxide. It says again, I say Portland cement reacts first with water by forming insoluble hydration products such as calcium silicate hydrate, and same time it forms a more soluble product, calcium hydroxide, which migrates through pore solution. GGBS reacts with excess free calcium hydroxide. GGBS reacts with excess free calcium hydroxide to form calcium silicate hydrates, CSH, which reduces size of capillary pores. Reduction in free calcium hydroxide makes concrete chemically more stable, and it restricts penetration of aggressive salts and sulfates to diffuse through concrete. It's discussed later in this. Okay, so what I say again, GGBS and water are complex. Portland cement, GGBS and water are complex. Portland cement reacts first with water by forming insoluble hydration products such as calcium silicate hydrate, and same time it forms a more soluble product, calcium hydroxide, which migrates through pore solution. GGBS reacts with excess free calcium hydroxide. GGBS reacts with excess free calcium hydroxide to form calcium silicate hydrates, which reduces size of capillary pores. A reduction in free calcium hydroxide makes concrete chemically more stable, and it restricts penetration of aggressive salts and sulfates to diffuse through concrete. So chemical hydroxide reduction is very important. Reduction of calcium hydroxide is very important, that to form calcium silicate hydrates, that is very imperative for this, so that there can be, you can say, capillary reduction occurs and concrete becomes more stronger, and it prevents aggressive salts to penetrate, sulfates to penetrate. Unlike GGBS, direct cement replacement, pozzolanaz, PFA, namely PFA silica fumes, metakaolin, MK, that is metakaolin, and rice husk rice husk RHA, and corn cob ash CCA. Again I say PFA, that is pulverized fuel ash, SF silica fumes, metakaolin, that is MK, rice husk ash RHA, and corn cob ash CCA, corn cob ash, do not contain enough calcium to form cementitious materials and need to combine with calcium hydroxide CaOH2, hydration product of cement, to form further strength, giving calcium silicate hydrate CSH. Most pozzolanaz, PFA, SF, RHA contain a large amount of silica SiO2, which reacts with calcium hydroxide to form strength, forming CSH. Calcium silicate hydrates. As a result, pozzolanaz have been characterized with a delayed strength development, as they only act as fillers before COH2 become available, but have been reported to gain strengths that are close to or above those of 100% cement at a later age, which can be up to 365 days. It has been reported, however, that concrete containing SF, RHA, MK exhibit impressive early age strength. Reaction between CaOH2 and SiO2, also referred to as pozzolanic reaction, is shown below. Calcium hydroxide silicate goes to calcium silicate hydrate, calcium hydroxide plus silica, that gives you calcium silicate hydrate, 3COH2 plus 2 SiO2, 3CaO, 2 SiO2, 3H2O. One time to note is once. One thing to note is once all calcium hydroxide has been completely depleted due to pozzolanic reaction, and unreacted pozzolanic material in concrete will have minimal contribution to strength. Noting is all calcium hydroxide has been completely depleted due to pozzolanic reaction, that's calcium hydroxide gone, and unreacted pozzolanic material in concrete shall have minimal contribution to strength, merely fulfilling role as filler. Due to limited availability of CaOH2 in concrete, cement substitute range using pozzolanaz is usually between 2.5 to 40% by mass, depending on type of pozzolanaz used and application of concrete. That's PFA. For PFA it is 20 to 40% for PFA, 5 to 20% for MK. So for PFA, for polarized fuel ash, it is 20 to 40%, 5 to 20% for MK and kaolin, that is 5 to 20%, and 2.5 to 10% for both silica fumes and RHA. As a result, most pozzolanic concrete contain highly depleted levels of calcium. Most pozzolanic concrete contain highly depleted levels of calcium hydroxide, which confers superior durability properties, namely sulfate resistance. Sulfate attack is a durability issue. That causes concrete to lose its compressive strength with Severity depends on type of sulfate. All commonly available water-soluble sulfates are deleterious to concrete. All commonly available water-soluble sulfates are deleterious to concrete with potentially severe effects. There are mainly two forms of sulfate attack of concrete. Magnesium sulfate MgSO4 and sodium sulfate Na2SO4. Higher sulfate concentrations in water are due to MgSO4 magnesium sulfate, which is highly soluble in water at room temperature 20 degrees Celsius when compared to Na2SO4. Both Na2SO4 and MgSO4 attacks have deleterious actions on concrete, but with different resultant effect. In sodium sulfate attack, Na2SO4 reacts with CaOH2 to produce gypsum CaSO4 to H2O, and or with aluminate C3A and alumina bearing hydration products to form attringite. Gypsum and attringite's precipitation in concrete could generate stresses within concrete, which, if greater than tensile strength of concrete, may bring about loss in strength, expansion, spalling, and degradation. In pozzolanic concrete, chemical reactions from pozzolanas help in resisting sulfate attack as they refine pores. Dilute C3A and remove CaOH2 by converting it into a cementitious material, thereby reducing quantities of gypsum formed. In contrast with cement hydration, CaOH2 does not precipitate on cement again, but in void space between gains of CSCM. Increased CSH content that results from pozzolanic reactions consuming and reducing amount of COH2 and aluminate hydrate CaAl2O4 and filler effect of unreactive pozzolanas can explain ability of SCM pozzolanic concrete to resist NaSO4 attack. The conclusion here is small conclusion, that is, cement industry is responsible for up to 10% of global carbon dioxide production. 10% global carbon dioxide production. During hydration of cement, reactions of calcium silicates and water leads to formation of calcium silicate hydrate CSH phase, which is strength forming compound in concrete. Calcium silicate hydrate. Calcium hydroxide CaOH2 is a byproduct of hydration of cement reaction. A pozzolanic reaction involves a secondary reaction whereby calcium hydroxide and usually silica SiO2 reacts to form strength contributing CSH phase. Due to secondary reactions, most pozzolanic concrete develop strength beyond 28 days and up to 365 days in some cases. However, eventually reach strengths that are close to or above those of 100% cement. Lower calcium hydroxide content in pozzolanic concrete leads to improved sulfate resistance. Lower calcium hydroxide. Now it says authors would like to acknowledge funding and support given by British Council's institutional links. Alright, so I'm just referring to you. I have taken this, and then there are many other, which are references in this. That's all I can say. So I think this is a useful paper for us. That's the reason it's gone. I gone. You can give something. Of course, a research paper, and I would like to save it as well if I can. No problem saving. I can say first levels and save it like this. So this is, I think, this is, I'm saving it. Maybe there is future. We can refer to future one. So cross current came. So I back to now corrosion resistance. Incorporation of corrosion resistance is talking about, because in between I came to this paper, though it's informative paper. It's good one. Now, incorporation of fly ash within concrete results in finer pores in high rated cement paste, leading to a decrease in permeability and chloride ingress rates. Properly proportioned fly ash concrete subjected to adequate curing should in general be less permeable at later stage than a corresponding Portland cement concrete, having similar 28 days strength, resulting in better corrosion protection for reinforcing steel. Fly ash shall generally increase chloride binding, leading to further improving resistance to rapid chloride penetration. Resistance to freezing and thawing. Resistance to freezing and thawing. Cycling of concrete is not affected by use of fly ash. This property is a direct function of air voids spacing factor of concrete that is obtained by proper use of air entaining admixtures. Fly ash concrete must have adequate strength prior to exposure to freezing, as is case for normal Portland cement concrete. Resistance to de-icing, salts, scaling. Laboratory test data indicates that fly ash concrete containing more than about 25% fly ash is less resistant to de-icing, salt, scaling than Portland cement concrete. However, some field data have shown that for acceptable performance of concrete incorporating more than 40 to 50% fly ash. Sulfate resistance. In general, low calcium fly ashes have been found to increase sulfate resistance of concrete. Low calcium fly ashes have been found to increase sulfate resistance of concrete. However, this may or may not be applicable for high calcium fly ashes. Alkali silica reactions. Alkali silica reactions. In general, inclusion of fly ash can mitigate expansion caused by alkali silica reactions in concrete. Amount of fly ash to be used for controlling alkali silica reactions depends on type of reactive aggregate, exposure conditions, alkali content of concrete, type of fly ash and water to cementing materials ratio of mixture. Amount of fly ash to be used for controlling alkali silica reaction depends on type of reactive aggregate, exposure conditions, alkali content of concrete, type of fly ash and water to cementing materials ratio of mixture. Published data indicates that percent replacement of cement by low calcium fly ash requires to mitigate alkali silica reaction may range from 25 to 35%. For high calcium fly ashes, there is some indication that effective replacement levels may be much higher than those for low calcium ashes. So low calcium, I think, serves low calcium fly ash requires to medicate ASR may change 25 to 35%. This is low calcium. Carbonation. Carbonation. I'm sorry. Use of fly ash decreases permeability of concrete. Use of fly ash decreases permeability of concrete, inhibiting easy penetration of carbon dioxide into concrete. When permeability of concrete is decreased, it's reduced. This means carbon dioxide cannot penetrate into concrete. We pack up because of fly ash. This is very fine, and you can say concrete permeability is reduced because of use of fly ash from 25 to 35%, low calcium, and this also results in the carbon dioxide cannot penetrate into concrete. It also reduces calcium hydroxide content in concrete. Because of that, calcium hydroxide content in the concrete are reduced due to pozzolanic reaction, consequently showing an increased propensity for carbonation. It also reduces calcium hydroxide content in concrete. Calcium hydroxide content in concrete due to pozzolanic reaction, consequently showing an increased propensity for carbonation. Fly ash concrete usually takes longer to reach same level of strength as concrete made without fly ash. Therefore, not properly cured fly ash concrete may carbonate more than Portland cement concrete, particularly at higher replacement levels. When carbonation is likely to be an issue, concrete with higher levels of SCM requires extended curing and or reducing in water cementing ratio. Water cementing ratio reduction is not that easy, but intensive curing, long-term curing can be possible. When carbonation is likely to be an issue, concrete with high level of supplementary cementing material requires extended curing and or reduction in water cementitious material. Durability in marine environment. Permeability is considered a major significant factor affecting durability of concrete in seawater, which is permeability is a major significant factor affecting durability of concrete in seawater. Evident that fly ash has good potent. It's evident that fly ash has good potential to improve concrete durability in a marine environment, provided it is well cured. Now, slag. GGF. Properties of fresh concrete as well as its mechanical properties. Properties of fresh concrete as well as mechanical properties and durability shall be influenced by inclusion of slag as replacement for Portland cement. Extent to which these properties can be affected depends on percentage of slag used and its fineness. Description outlines manner in which replacement of Portland cement by slag affects properties of concrete, let us say properties of fresh concrete. Slump and workability. GGBS improves workability and cohesion of concrete, but greater importance is obtained with higher GGBS content. High value of GGBS doesn't improve workability of concrete. High value of fine GGBS doesn't improve workability of concrete. Bleeding. Use of slag does not have a significant influence on bleeding of concrete. Autogenous temperature rise. Autogenous temperature rise. Use of slag may reduce autogenous temperature rise in concrete elements as well as associated risk of thermal stress and cracking. If sufficiently large percentages of slag being used as partial replacement for Portland cement to at least 50%, provided slag is not ground to very high fineness, that is greater than 6000 Blaine. Again, this is very important one. The use of slag may reduce autogenous temperature rise in concrete elements as well as associated risk of thermal stress and cracking. If sufficiently large percentage of slag is used as partial replacement for Portland cement to at least 50%, provided slag is not ground to a very high fineness greater than 6000 Blaine. Higher levels of replacement greater than 65% may be required for concrete in warm weather conditions. Setting time. Setting time of slag concrete may be longer compared to Portland cement concrete, particularly in cold weather. Slower set shall depend on reactivity of slag and its percentage used. This may influence schedule for finishing network, flat work surfaces, particularly for higher volume replacements such as more than 40%. Due to its slightly slower strength development, slag concrete is more sensitive than conventional concrete to cold weather conditions for concrete replacing. This may further slow setting time of slag concrete. In warm weather, setting times are similar to those of Portland cement concrete. Mechanical properties. Strand development. Let us say we go and open this. It's time, I think. Just a minute. 5 minutes, just please. I'm going. Strength development. Strength development. In general, concrete containing GGBS gains strength more slowly, tending to have lower strength at early ages and equal or higher strength at later ages compared to that of Portland cement concrete of similar 28 days compressive strength. However, at an equivalent replacement level, effect is comparatively less than that of most fly ashes. Again I read, in general, concrete containing GGBS gains strength more slowly, tending to have lower strength at early ages and equal or higher strength at later ages compared to that of Portland cement concrete of similar 28 days compressive strength. However, at an equivalent replacement level, effect is comparatively less than that for most fly ashes. In hot weather, strength gain can be as high as higher than Portland cement concrete. Slightly slower strength development and resulting lower early age strengths of slag concrete might be a problem for foam removal in some cases when high percentages of slag are used, particularly in cold weather conditions. As far fly ash is concerned, this can be overcome by a judicious proportioning of concrete mixture, such as reducing water-cement ratio or adding silica fume or to produce a ternary bland. Drying shrinkage. There is no significant difference in shrinkage characteristics of concrete with and without GGBS as part of cementitious material if paste content is same. Also, advantage may be taken of improved workability and associated water reduction achievable with GGBS. Creep GGBS appears to reduce creep due to increase of ultimate strength and elastic modulus of concrete with GGBS. However, if concrete is loaded at early ages, creep might be higher than that of Portland cement concrete due to lower gain of early age strength of concrete with GGBS. Durability characteristics. Inclusion of GGBS in concrete increases its resistance to chlorides, ion penetration, particularly at later ages. Resistance to chloride ion penetration. It also improves chloride binding, which is very advantageous for protecting reinforcing steel from corrosion, for which requirement slag concrete should be well cured as applicable for fly ash concrete. Resistance to freezing and thawing. Resistance to freezing and thawing. Resistance to freezing and thawing. Cycling of concrete is not affected by use of GGBS. Not affected. This property is a direct function of air voids spacing factor of concrete that is obtained by proper use of air entraining admixtures. Concrete must have adequate strength prior to exposure to freezing, as is case for normal Portland cement concrete. Resistance to de-icing salt scaling. As for fly ash concrete, laboratory data indicates that slag concrete is slightly less resistant to de-icing salt scaling than Portland cement concrete, which limits percentage of slag that can be recommended in concrete flat work exposed to de-icing salt to less than 50%, although there are some contradictory results on this. Again, as valid for fly ash concrete, laboratory data indicates that slag concrete is slightly less resistant to de-icing salt scaling than Portland cement concrete, which limits percentage of slag that can be recommended in concrete flat work exposed to de-icing salts to less than 50%, although there are some contradictions. Sulfate resistance. Concrete containing GGBS dosages greater than 35% by mass of cementitious material has demonstrated an improvement in resistance to sulfate attack. Has demonstrated an improvement in resistance to sulfate attack. For equivalent performance to type HS cement, slag levels of 35 to 65%. 35 to 65% may be required depending on Al2O3 content of slag. Increasing slag levels would be required with increasing Al2O3 content in slag. Resistance to alkali-silica reactions. Inclusion of slag in adequate percentages, usually more than 35%, can be used to mitigate expansion caused by alkali-silica reaction in concrete. Carbonation. As for fly ash concrete with GGBS, if not properly cured, may carbonate more than Portland cement concrete. Durability in marine environment. Permeability is considered major factor affecting durability of concrete in seawater. Therefore, it is evident that GGBS has potential to improve concrete durability in marine environment, particularly given slag performance in chloride environment. Now there is a table that gives a summary of general effects of fly ash and GGBS on concrete properties. So there's a table. Let's go through this. Better understanding for this. This reference I don't actually remember from which I took this one. Well, no problem. The general, In this, there's GGBS on concrete properties, comparison with Portland cement concrete, similar 28-day compressive strength as fly ash. As GGBS, and then there's comments. Water demand, fresh properties of water demand. In both cases, fly ash, water reduction decreases with increasing fineness and carbon content of fly ash. Means what? Says fly ash. When you use fly ash, water reduction decreases with increasing fineness and carbon content of fly ash. GGBS does not have a strong effect on water demand. Workability, let me just put it off. Workability. Fly ash, in case of fly ash, spherical particles shape of fly ash assists in improving workability, and in case of GGBS does not have a strong effect on slump but increases pumpability. Bleeding. Fly ash, bleeding and segregation are in general reduced and pumpability is improved. However, low bleed water may increase risk of plastic shrinkage, cracking. In GGBS, does not have a strong effect on bleeding, setting time. In case of fly ash, longer setting times compared to normal concrete, which may affect finishing schedule. Cold weather conditions may further slow setting times. GGBS, its effect on setting time is less than that of fly ash. Autogeneous temperature. Fly ash generally reduces risk of thermal stresses and cracking, especially type F and CI. GGBS may reduce risk of thermal cracking if at least 50% is used. GGBS may reduce risk of thermal cracking if at least 50% is used and blade fineness is lower than 66,000 centimeters square per G per gram, and if at least 65% is used in warm weather. Mechanical properties. Compressive strength, flexural strength, modulus of elasticity, drying shrinkage, creep. Mechanical properties, and these were we discussed before were fresh properties, mechanical properties. Compressive strength, fly ash. It decreases mechanical properties at early ages, especially one day and in cold weather. Long-term mechanical properties such as compressive and flexural strengths and modulus of elasticity of fly ash concrete are typically superior to those of Portland cement concrete of similar 28-day compressive strength. And in GGBS, similar behavior to fly ash concrete, except that slag concrete has higher early age mechanical properties and lower long-term mechanical properties compared to fly ash concrete with similar contents. Drying shrinkage. Fly ash long-term drying shrinkage and crepe of fly ash concrete shall be similar to or lower than Portland cement concrete of similar 28 days compressive strength. GGBS appears to reduce crepe. GGBS appears to reduce crepe and has no significant effect on drying shrinkage. Durability. Permeability, corrosion resistance, sulfate resistance. Durability, permeability. Fly ash reduces water and chloride ion permeability, especially at later ages if well cured. GGBS similar to fly ash. Corrosion resistance. Fly ash increases potential protection of reinforcing steel from corrosion if well cured. GGBS similar to fly ash. Sulfate resistance. Fly ash use of low calcium fly ash CSA class F and C1 with CaO content less than 20% increases resistance to sulfate attack. Fly ashes more than 20% CaO should be investigated for sulfate resistance, rarely used. GGBS content required should be investigated, usually more than 35% is required. Concrete mixture proportions. Procedure indicated below for selection of mixture. Proportions used for Portland cement concrete is also applicable to concrete incorporating inclusion of either fly ash or slag with some modifications. For concrete durability, supplementary cementing materials. Let's see this also. For concrete durability, supplementary cementing materials. Estimation of mixing water and selection of air content. Estimation of mixing water and selection of air content. Selection of water to cementitious materials ratio, water cement material ratio to meet durability and strength parameters. Calculation of cement content. Calculation of coarse aggregate content, calculation of fine aggregate content, selection of admixture doses, rates, adjustments for aggregate moisture, trial batch adjustments. Very important point that we must do. We have gone through already this file, I think. We have gone through this with new requirements. No, we have not gone through this. We have to go through this. We have to go through this. No, we have not gone through this. This is chapter 3. And if you see chapter 4, chapter 3 is already open. 4 is open. Five is construction controls facilities petrochemicals. Construction and control. Mobilization. So this is also a very important chapter. We'll take up this also. Let's take this. We are doing this one, and this was saying that it will continue like this. Page 12 is also detailed talk. Sorry, gentlemen, I'm yawning. Oh. Oh. Its file says that, or says, it's the front, I think. Yes, that's the file. That's the file. Engineering facilities. Not this one. This one, I think. No. Engineering facilities. This was this one. This is the file I actually opened. That one. So engineering facilities. What is that? Let us see what is facility about. Company and engineering. All that we see. General requirement. This is file number 3. Okay, this is also important. And we have construction file, construction controls. We have this files here. Facilities file 3. So we are going to this estimation of mixing water, and selection of air content. It's a very important part. Estimation of mixing water and selection of air content, selection of water to cementitious material, water cement ratio to meet durability and strength parameters, calculation of cement content, calculation of coarse aggregate content, calculation of fine aggregate content, selection of admixture dosage rates, adjustment for aggregate moisture, trial batch adjustments. These steps we dictated depending on method used for incorporation of fly ash of the GGBS in concrete. Again, it's a estimation of mixing water and selection of air content, selection of water for water cement ratio, calculation of cement content, coarse aggregate, fine aggregate, admixture dosage rates, aggregate moisture, trial batch adjustments. These steps may dictate depending on method used for incorporation of fly ash or GGBS in concrete. Simple replacement method consists of a direct replacement of a portion of Portland cement by fly ash or GGBS. Consists of, again it's the mask, let me talk, use it sometimes because of body burning. Consists of a direct replacement of a portion of Portland cement by fly ash or GGBS on 1-for-1 basis, either by volume or by mass, which mainly consists of modifying an existing Portland cement mix to include fly ash or GGBS without other adjustments. Concrete designed with this method usually has lower performance compared to that of concrete made with Portland cement only. Modified replacement method consists of developing fly ash or GGBS concrete mixtures with similar workability and similar compressive strength to that of Portland cement concrete at a specified age. In general, such concretes have a higher total weight of cementitious materials and lower water cement than that of Portland cement concrete. Estimation of Estimation of mixing water. As mentioned earlier, use of fly ash in concrete generally reduces water demand required to achieve a certain level of workability, while use of GGBS does not significantly affect water demand due to the fact that fineness can be controlled by keeping to determine limit degree of granulation. Therefore, for each type of fly ash and fly ash content, same criteria for GGBS to some extent. Data should be developed to replace values for different slumps. As mentioned earlier, use of fly ash in concrete generally reduces water demand required to achieve a certain level of workability, while use of GGBS does not significantly affect water demand due to the fact that fineness can be controlled by keeping to determined limited degree of granulation for each type of fly ash and fly ash content, and same criteria for GGBS to some extent. Data should be developed to replace values for different slumps and nominal maximum size of aggregates. Mixing water is also dependent on sand gradation. Unit water content of concrete mixture designed for long-term durability should be as low as practical. Consideration should always be given to using water reducing admixtures. Consideration should also be allowed for constructability of concrete placement. Selection of water cementing material. Selection of water cementing material is related to durability requirements and to specified compressive strength, usually at 28 days. Use of fly ash and GGBS affects strength development of concrete. Use of fly ash and GGBS affect strength development of concrete and consequently relationship between compressive strength and water cement ratio, cementing material ratio. Trial batches can be made in order to develop this relationship. Design of laboratory program. Design of laboratory program would preferably use a factorial design. Design of laboratory program would preferably use a factorial design optimization method. Factorial design optimization method that provides with a minimum of well-planned trial batches. Possibility to explore a large range of compositions. Design of laboratory program would preferably use a factorial design optimization method that provides with a minimum of well-planned trial batches, possibility to explore a large range of compositions. Relationship shall also depend on type of fly ash, GGBS type of cement used, curing conditions and curing procedures. In general, to achieve similar early age strength up to 28 days as for a Portland cement concrete, fly ash and slag concrete might require lower water cement ratio. Given equation respecting fly ash and slag contents may be satisfied. That is Fa over 40 plus S over 45 is greater than 1. Fly ash over 40 plus slag over 45 is greater than 1. This means what? Fa fly ash over 40 plus slag over 45 is greater than 1. Maximum water cementing material of concrete should meet defined requirements except when concrete is exposed to freezing and thawing, in which case required values should be reduced by 0.05. Also, for reinforced concrete elements exposed to moisture and air with depth of cover less than 50 mm, for reinforced concrete elements exposed to moisture and air with depths of cover less than 50 mm, water cementing material should not be greater than 0.4. For HVSCM1, and that is Fa over 40 plus S over 45 greater than 1, not greater than 0.45. For HVSCM2, Fa over 30 plus S over 35 greater than 1. We'll take this later on. After all, quality everywhere is important here. Quality everywhere is a very important factor. You have to consider quality. Quality everywhere. Everywhere. In every material, in every action, in every statement, performance, time. Everywhere it should be. Everything is analysis we are doing, we are talking about. It's all analysis. And of course thinking based on whatever we have. So we should go like this, only way. No other way out. Can't go somewhere else. You have to already gone through this to some extent. We gone through this to some extent. Then how far we have gone, we are not going to totally. Very important one. This is chapter 2, we have to go through this also. Go through this also, yes, it's right, okay, we have to go through this also. I'm just finding out which we have to plan now, see, where is this, and this server, where we are? Well, we are covering certain directions, certain talks and certain subjects, or certain scope of ourselves. That's very, very important from every point of view. You can say it's very important from that point or this point. It means reasonable. So the reasonable, acceptable. We have to understand what we know. So we have studied today about PFA, SCM, and details of on paper of on PFA, and also the SCM, that is GGBS. Have to grasp all this. It's very important from every point of view. You cannot just not jump on, but understand details of this for better grasp rather than just running and running. Running is not our style, so later on we'll talk this